today's webinar on unlocking the power of distributed data with the GridOS Connect and Data Fabric. My name is Paul Yates. I'm Principal Solution Architect with GE Vernova in the Grid Digital Software Group. We've also got on the line here Thorsten Heller, who's our Chief Innovation Officer for Digital Grid Software Group within GE Vernova. We'll get started right away. So over to you, Thorsten, to start off the presentation.
Wonderful, and thanks for having me. For those of you that don't know me, Paul already mentioned it. My name is Thorsten Heller. I'm based in Oslo, Norway. And what we're going to do today, we want to talk about the power of data. We want to talk about GridOS Connect. We want to talk about the data fabric. And today's focus is on data, on distributed data. The focus is on distributed energy data, or how can we unlock it to create value for utilities. And to start up and to set the scene, I want to introduce a concept that I believe is quite important for the future utility. And the concept is called the platform utility. And when I think about the platform utility, what we mean is I want you as a starting point to think about the future grid from an infrastructure point of view, Paul. So what I want you to do is now to think both on the grid infrastructure first, and then we're going to link it to IT. But when you think about what is happening in the grid right now, when we think about how the grid will develop, we are moving into a world that you as a utility, you must be able to operate an end-to-end network with more and more assets in the network that you might not own and you might not know. As an example, more and more DERs. You get more and more EV charge points. You get more and more solar panels. So as a utility, we are moving into a world where you should think your grid infrastructure like a platform, and you can plug in any kind of an asset. Does it make sense, Paul?
Yeah. And the sheer volume of data that's associated with that, and the new types of data and the new types of sensors and equipment that have been put into the grid to manage it. Exactly. So the problem of managing that data is where we're headed in this discussion. Yes.
No doubt. And that is exactly why we call it the platform utility. Because on the one side, you have to think about your grid infrastructure as a platform to be able to put more sensors, assets, things like it in the network. But on the other side, you also have to think the same from an IT point of view. Because to manage the end-to-end grid in the future, you might need to integrate data sources that are not your data sources anymore. You might want to integrate weather data. You might integrate data from the government or public institutes where you are getting information about flooding, things like that. So also from an IT point of view, you have to think platform to get the possibility to plug in different data sources, to present data to others. So one of the core concepts is exactly the platform utility. And when we are implementing this kind of a platform utility, then the backbone for the platform utility is indeed, as you said, Paul, the data. The data, distributed data, and that is one of the core components here. So when we talk now about distributed energy data, then we also have to talk about the 6 V's of big energy data or distributed utility data. Have you heard about the 6 V's, Paul?
Yes, I have in the past, but I'm sure that it's a very important way of categorizing the type of data that's managed within a distributed utility, a distribution or transmission utility. Yeah. So
exactly. You know what I'm talking about, but we can
I do. Yes.
anyway. We can quickly recap on that because
Let's do that. Yeah.
there are several aspects. So when we talk about distributed utility data, so first of all, let us just do some examples. What are the kinds of data we're going to use in the future? You remember the platform utility. You remember that as a utility, you must be able to orchestrate, to manage the end-to-end grid, where you might also want to use data coming from external data sources, where you might want to have data from the geo network management. You might want to have data from smart meters. So the typical data we are talking about is data like, of course, operational data, SCADA data, EMS data, ADMS data. Let's call it grid data. The other data you typically want to use is, of course, data from your geo network management. You might want to use asset management data. You might use customer data or kind of information about the consumers. You might want to use sensor data, behind the meter data. So you might also want to use maybe data coming from a cloud provider. I already mentioned weather data. I already talked about flooding data, things like that. So there are many different data sources, and that is extremely important. We are not only talking about the data coming from the control room or coming purely from the geo network management system. We are talking about integrated, distributed data that has different data types, and that is maybe.
Yeah, I was just thinking around. When we take data and put it together, we're trying to add value there. But one of the key elements about understanding that data is understanding, maybe what is good data. So how do we ensure that we understand how we use that data is a good use case or a valid use case. So what is good data? Yeah.
And so, then I have an idea, Paul. Before we discuss quickly what we mean with good data, let us quickly recap the 6 V's. Because what we already spoke about is all the different data types we want to use. And I'm quite sure when I spoke about grid data, sensor data, behind the meter, geo network, enterprise asset, weather data, whatever, there are many other data sources too. But what is also important, and that leads in the end to the good data discussion, what we have to think about now is that we are moving with all the data types and all the use cases, how we want to orchestrate the network, the grid in the future, we are moving into the 6 V's. And the 6 V's, the first one is, of course, volume. We are getting more and more data, meaning with all the sensors in the network. If you are combining SCADA data with all the sensor data, with smart meter data, so we are getting a vast amount of data. So the V number 1 is the volume. The other thing is, of course, also, I already spoke about it. We get more and more different data types. So it's not only SCADA data anymore. It's not only alarms and events anymore, but it's also asset data, behind the meter data, it's external data, so more and more. And then also important, most of the use cases in the future are moving towards real time. So the speed of the data, it's not only big data, it's also fast data. And then, of course, when we are getting more and more different data types and more different data sources, there is also a quality challenge in it, because sometimes you're going to get all of the data. Sometimes you suddenly will have 0 values or no values. Another challenge here. And then there's another aspect to that. The data types might change also, because you have many different vendors involved that are upgrading APIs. And the last V, that is the value. You get so much data that you also get a lot of noise. And it means now, when we talk about the data, we have to put it in the context that we are now starting to combine data that is coming from OT with IT, with enterprise and the cloud, all the different data types, but we are in the context of handling these things. And what does it mean now when you and me say good data? So what is your definition of good data, Paul?
Yeah, well, I guess you've got to have an understanding of how accurate that data is. You've got to have an understanding of what the source of that data is. Who owns that data maybe, when does it get updated? The data itself, the data without that extra information is sort of an unknown. It's a bit of an unknown source, and so if you want to use that data to make important decisions about the way you manage your network, then you certainly want to know what the lineage of that data is, where it's come from, who's collected it, who owns it, all those sorts of things. And even then, the accuracy, obviously that's sort of a given. But even if you're confident of the accuracy, you still want to know where it came from before you start using it for important decisions. Yeah.
Yeah, exactly. Totally agree. So when we think about what I spoke or what you and me discussed now, all the different data, the distributed data in combination with the 6 V's, good data means exactly what you said. A good data is so important because when you are running, to give you some examples, if you are running the DER forecasts, you must know that you are running DER forecasts on good data, the data that is accurate, the data that has been updated with the frequency you are expecting. You must understand the meaning of the data. You must trust the data. You must have confidence in the data. Think about it. If you are doing automated grid decisions and you cannot trust the data, and exactly these kinds of questions are the questions we have to answer when we talk about good data. But Paul, before we move on, I have one of my favorite slides, and I just want to explain it to you.
Sure.
Because we talk about good data, but we also have to talk about the reality today. And let me start with the 80-80-80 challenge for utilities. And Paul, you and me, we have discussed it before. I'm quite sure you have heard me talking about the utilities 80-80-80 challenge many times, but still, let me repeat it once again, because I get quite passionate about it. So when you think about all the AI and ML pilots in the world that utilities are running and starting, what do you think, how many of them make it in production? Oh, that is unfair because you have the answer already on the slide.
Yes.
Yeah, now it's easy. Okay, then I can make it short. Less than 20% of all AI ML pilots utilities are starting still make it in production. And do you know the reason? The reason is bad data. Because when we are moving AI ML pilots into production, then we have to integrate it into the workflows. We have to integrate it with the operational systems. And that is where one of the biggest challenges is happening.
Yeah, also, we've discussed this before around data preparation, how, we've got people that spend a majority of their time, just preparing data and changing formats and understanding the data source as well, where 80% of their time is spent just manipulating data rather than getting on with the real work around data science and so on. Yeah,
exactly. And that is, by the way, something one of my Norwegian clients, they told about the data science team they have And then when we started to do a deep dive and analyze what are they doing, then exactly what you said, Paul, the data science team is spending more than 80% of the time on just making data accessible, preparing data, cleansing data, putting some context on the data to make the data understandable. So that means less than 20% the data science team is spending on science, on innovating. But 80% they are just spending on preparing the data foundation, the good data foundation we spoke about. And the last of my 80%, that is the dark data. And dark data, for those of you that don't know what I mean with dark data is data you have as a utility somewhere, but you are not able to use. Data that might be hidden in a silo, data that might be collected in your smart meters, but never transmitted from the smart meters to your software solution. That might be data you collect, but you don't understand the meaning of the data and you store it somewhere. That might be video data you have, but you never use. So dark data is in the end the data you have available, but you are not using or you are not able to use. And there is research in the market that a utility typically operates on 80% dark data. So when I talk about the 80-80-80 challenge utilities are having, then it's exactly the 80% dark data that utilities have. And just think about if we would be able to enlighten or illuminate the dark data, how much value would we be able to create out of that? Or when you think about that, a data scientist is spending still 80% of the time just preparing data, making data accessible. Think about how much value we would create if we can provide the good data foundation. And you, Paul, as a data scientist, you could only focus on innovating on science. And of course, the last one, if we would provide the data foundation, the good data foundation, that is both providing good trainings data, but also the operational backbone of data, that most of the AI ML pilots also can make it into production, then we would have created the data foundation that utilities need. So that is when we talk about the challenges we are seeing with the utilities, the 80-80-80 challenge. But the interesting question is, why do we have this 80-80-80 challenge? And one of the things, and that would be interesting for me, of course, to know from you, Paul, if you agree, and of course from the audience too, one of the things I see is we just have siloed applications. We have too many as a utility. Utilities are still operating too many siloed applications, meaning applications, solutions that have been implemented maybe 20 years ago with technology that was up to date 20 years ago for the use cases that were required 20 years ago. But now we are moving into a distributed world and these systems are just locking data. So one of the core challenges I see with many of our clients is that we have siloed applications and it's hard to get data out of these siloed applications. You agree?
Oh, absolutely. And you know, like you know, the use cases for taking, you know, data from different applications, say from an OMS and an AMI system, and then putting them together to understand, you know, more about your network models or something like that. Because of the way the systems are siloed, they sometimes have some point-to-point integrations, but if you want to go further with actually integrating for operational reasons, but if you want to go further for actual integration of the data for different purposes, because there's value in that data that can be unlocked when you actually bring the data sets together and analyze them as analyze them together. Yeah.
Yeah.
So
another challenge, by the way, Paul, I also see sometimes is that many of the applications the utilities are running today, operating today, are built on bespoke technology. So they have never been built with interoperability in mind, exactly what you spoke about. And then it's, of course, hard to exchange data, and not only exchanging data, but as we are using a lot of bespoke technology, and as we are using also a lot of bespoke data formats, it's quite hard. And now I'm using your example to understand that geo network model as an example. So it's not only about the silo data, but it's also about the bespoke technologies and the bespoke data formats. So if we want to build this good data foundation, we have to break up the silos and we have to put meaning on top of the data. Cool.
Yes.
And Paul, I might just apologies just to chime in. We've got some questions coming in, which is great. We've got a question. Might be worth just answering this now if you guys can, from Vivek at AMO. So the theme of today, GridOS, Data Fabric, and Connect, is this already in production for a utility, a transmission or distribution utility, or is this a sort of a future roadmap or a concept piece? If you guys would be able to address that, that would be great. Thanks.
It is already in production. So what we are talking about here is not a concept. We are talking about a real implementation where we have clients both on the distribution side and on the transmission side using the concepts and using the platform, meaning GridOS Connect and or Data Fabric. And the typical use cases we are seeing here, and that leads, by the way, Chris, that was perfect that you chimed in, because the typical use cases we are seeing that clients and utilities are implementing, I could separate or categorize those use cases in 6 different areas. And that helps maybe to understand. So we have one area, and that was also something Paul was mentioning, where our clients are using the Data Fabric and GridOS Connect. And by the way, in 2-3 minutes, we are coming back to the different components, what they are doing. But where clients are using the platform for grid planning and grid analytical use cases. Paul mentioned already the exchange of geo network data, but now you can also think about use cases where you are starting analyzing the quality of your assets, the asset health, where you start putting planning algorithms around to find out how is the network developing in the next 5 months or 12 months, things like that. So one area of use cases that have been implemented and that utilities are implemented at the moment on the platform is related what I call grid planning and analytics part. The second set of use cases where clients are implementing the platform is related to disruption management and outage management. Meaning, as an example, there are failures in the network, and when you are now able to combine it, as an example, with smart meter data, it means you are much faster to find out where problems are. You might be much faster understanding which clients are affected. You might be able to faster dispatch teams to fix the failures. So there are many use cases related to disruption and outage management where you would use distributed data coming not only from the operational systems, but also coming from the IT world, from smart meters, from sensors. The third area where we are seeing many of our clients implementing those concepts or the GridOS Data Fabric as an underlying foundation is what I would call grid management and orchestration, where we are also moving into the world of DRs, where we are moving into managing, orchestrating the end-to-end grid, where we are moving into a world where we must move to more and more real-time management of the grid infrastructure. The fourth area is where we see clients implementing the platform is related to what some people would call AMI 2.0, or what some people would call prosumer engagement, meaning use cases where you as a distribution service operator might want to let the consumers or your clients be part of the energy transition. That is exactly the prosumer engagement, where you are creating signals to the client. So the AMI 2.0, the update on the smart metering infrastructure, combining it with grid edge data to create prosumer engagement. Fifth area where we are seeing the platform used today is related to grid balancing, market communication. We need more and more interaction also between distribution service operators and the transmission service provider. So all these use cases. And the last typical use case we are seeing is related to flexibility management. To market participation, we see more and more needs to implement or realize a kind of flexibility market, demand response programs. And when you think about all these use cases I was talking about, all these use cases are based on good data, meaning data that is on time with high quality data, understandable data, data that is put into a given context, data where you as a user of the data know the quality of the data, you can trust the data. All of these are based on the same concepts of distributed data. And the important thing, distributed data. It's not only data from one silo, it's really distributed approach. And that would also lead me to the data fabric, Paul. And I think it's maybe a good time to quickly run through what the data fabric is doing.
Yeah. I might jump in and have a discussion about. Well, we've talked through a number of different elements around data silos, dark data, data formats, and some of the use cases that sit on top that a utility in the future is going to need to work with. So from that perspective, we've looked at putting together what we call the data fabric, and the data fabric is several components that are driven from the ideas that we've spoken about so far. One of the key components, I'm going to start in the center of the diagram on the left there, that is the Discover catalog, right? For me, that's the heart of the data fabric. Now, the Discover catalog it's about that metadata management. So you get to be able to understand what data is available, where it lives, who updates it, who maintains it, what the quality of that data is to some degree, and also how you access it, who owns it, all those sorts of things. But beyond that, it's not just a metadata catalog, if you like, or a table, but there are ways that we derive lineage of that data, and how data is put together into different data products, and how those data products are combined together to generate new data products, and they could be an analysis or so on. When we describe lineage of that data, we get to also understand where that data is used, who might be impacted by a change in that data. So if I'm going to make some change to the source system of that data, what other analytics downstream might be impacted from that data. So the Discover catalog, it's a searchable catalog as well, is a really important component of that overall data fabric, and that enables you to really manage your data sources, and also define how you can put and plug data together to make new data sets and so on. So that data catalog for me is the heart. It's the heart of the whole data fabric. Okay,
And
so then
to be fair, sorry for interrupting.
Yeah,
I totally agree with you, because what you just described, the Discover catalog as a component, gives you exactly, now I simplify, I'm not a native speaker, so I make it quite easy. It's in the end the component that is providing you the tooling support that you as a user of the data fabric, of the data as an operator, can get the confidence in the data, the trust in the data, the understanding of the data. I totally agree with you. It's one of the core components. But I want to highlight another component, because I also saw some questions in the chat to Yes. Because another quite important component in the data fabric is here the component that is called GridOS Connect. And GridOS Connect is an integration component, a middleware, an enterprise service bus, whatever you want to call it, but it's purpose-built for utilities. And purpose-built for utilities means, and now I'm answering one of the questions in the chat, the question was related to the traditional gap between IT and OT, or to turn it around, how can the data fabric bridge the IT-OT integration gap? So GridOS Connect is an enterprise service bus, a middleware, an integration platform, whatever you want to call it, purpose-built for utilities. And part of this purpose-built for utilities, we have built-in support to handle a secure IT-OT integration, bi-directional. So in GridOS Connect, you can, or to turn it around, you would use GridOS Connect to integrate all the disparate data sources at scale. And if you have to traverse IT-OT or OT-IT, then you can configure the platform to securely manage and enable a bi-directional connection or message exchange between the different platforms. GridOS Connect also provides a series of templates to integrate with third-party applications, not only GE Vernova applications. It is built as an open platform, highly scalable platform that can be integrated, that can be used to integrate data sources on-prem, data sources in the cloud, data sources in the enterprise. Could be systems like SAP, could be IBM Maximo as an asset management, can be Geo Network Management System, can be SCADA. So it is a utility-focused integration platform with built-in IT-OT integration support. Yeah. But Paul, maybe would be interesting if you quickly can also explain how we organize the data, how we store the data.
So the other two main components there, any-based data store and time-based data store, they're very highly optimized engines for supporting the data fabric. They use technologies that can draw data from your existing systems via Connect if necessary, and present it in a way that can be very, very highly optimized ways be analyzed and queried. So AnyBase is part of the solution there, as well as TimeBase to support time-based data as well. So those two components form important components of the overall data fabric solution. They provide for taking data from its source and building it into an environment that can be quickly analyzed and worked with. The organizer workflow that also plays its part in supporting the whole data fabric and supporting pipelines of data coming from different systems as well. And all that together is great, but we have sitting on top of this as well a self-service sort of Explore BI platform, which will enable you to build up your dashboards and access information about the Discover catalog, and really self-serve access to data, as well as provide a platform for visualizing that data as it exists in the data fabric. So there's some other key components of the solution as well, and they're all packaged together and delivered together to form that solution as a data fabric to meet the requirements that we were talking about earlier around breaking down the silos, around understanding the quality of data, around those key pieces of information we were talking about earlier to support. All right, so
maybe, Paul, because I have seen several questions in the chat, maybe I can quickly repeat the 4 main capabilities we are having in the data fabric and then link it back. So capability number 1, I already mentioned, it is related to integration at scale, disparate data sources. This component is called GridOS Connect. And what is maybe important, and I saw some questions in the chat, so I try to answer it right away. GridOS Connect can also be delivered as a standalone component. So for scenarios where you as a utility must implement, or your focus is on the exchange of data, the integration of different data sources, you can implement GridOS Connect. And compared to a traditional ESB in the market, the most important difference is what I called the utility-specific implementation. So compared to other ESBs, GridOS Connect provides OT/IT integration support. GridOS Connect is built for highly scalable real-time data. So when we are talking about exchanging a huge amount of data, GridOS Connect is built with security in mind. So all the integrated data sources are authenticated, authorized correctly using zero trust. GridOS Connect has also a set of advanced capabilities for error handling. So think about an ESB, a middleware purpose-built for utilities, providing also a huge set of templates to integrate with different CRM systems, with Salesforce, with different metering vendors, with different sensors, all the capabilities you typically on a traditional ESB would have to implement on top. By the way, I also forgot GridOS Connect can also handle, as an example, SIM-based data exchange. SIM is a typical standard. So one of the questions, as I said, was related to what is the difference between Connect and the traditional ESB. All the utility-specific integration artifacts you would implement on a horizontal traditional ESB are already available in GridOS Connect. So integration at scale, that is capability number 1. The second capability that Paul spoke about is then how we store, organize data, and that is where we are providing in the GridOS Data Fabric managed data services where we can store a huge vast amount of real-time data in our in-memory database called Anybase, and we can also snapshot the data in Timebase. Then the data fabric is providing engines where semi-technical users can build own dashboards, operational reports called the Explore BI platform. We can also build data-driven workflows in the data fabric. And the last of these 4 capabilities, and that was what Paul highlighted, is related to curating and building data products, meaning building out the metadata catalog that makes sense of the data, that defines the quality of the data, that monitors the quality of the data. And all of that integrated into one platform. So 4 capabilities: integration, storage, organization of vast amount of data, how you use the data, either in an interactive dashboard or using workflows and APIs. And the last capability, creating the semantic integration, the metadata catalog, the governance tooling support you would need. That makes sense? What we forgot to mention all is that the platform is built as an open platform, because that means our clients and our partners can build applications on top of it.
Yes.
It's not limited to GE Vernova application, but you can also build your own operational reports on top of it. You can build your own AI services on top of it, or you could integrate third-party applications. And that means with the GridOS Data Fabric, we are giving you as a utility the flexibility of choosing either a best-of-breed approach, or you want to say there are some kind of applications where I want to provide my own functionality, but I want to move as much as possible into a commercial off-the-shelf world. So with the GridOS Data Fabric, the openness in mind, the capabilities to integrate across the entire network, we are giving you as a utility the platform to choose from an IT strategy point of view, whatever strategy fits best into your scenario.
Yes. That's important as well. To I guess that sort of touches on what's on the right-hand side of that slide as well a little bit, in the way that the GridOS Data Fabric is deployed as a solution, and the fact that it is a containerized infrastructure using cloud-native technologies that can be deployed on-premise and or in the cloud, in your OT environments and or in your IT environments, through making use of composable microservices and building up your distributed and federated data products. So by using those cloud native technologies, we get the security, we get all those non-functional requirements, high availability, all those sorts of things as part of the underlying platform to GridOS Data Fabric as well. And I do see a question in there around whether Connect can be deployed as a cloud-based IT platform or to an OT platform. Well, the choice is yours. We can support both, or even a hybrid architecture. You might have some of your data fabric deployed in the cloud or an instance of it, and have an instance deployed in your OT network and manage the sharing of data from OT to IT, and the sharing of semantic information, the sharing of that discovery catalog across the organization as well. So,
and by the way, Paul, sorry for interrupting. I get excited now because when I see all the questions in the chat, I just get into excitement mode. But what you spoke about, the cloud native nature of the platform, the containerized infrastructure, that is also, by the way, one of the big differences compared to the traditional horizontal platforms like a MuleSoft or like a TIBCO, like a WebMethods. Because GridOS Connect and the Data Fabric have from the beginning, from the start, been designed as containerized applications, cloud-native technologies, because what we want to enable, and you already described it, is the possibility to operate it and deploy it on-premise, in IT, in a private cloud, in a public cloud, but even more important, in a hybrid integration scenario. That means in an integration scenario where you might run the GridOS Data Fabric and Connect in OT, but you want to enrich it with data coming from your enterprise IT or cloud data or vice versa. So GridOS, the Data Fabric, and GridOS Connect are entirely built on cloud-native technologies, containerized infrastructure, giving you the flexibility to choose which deployment model, which operations models is the best one, but it's also supporting these hybrid integration scenarios that we're going to see in the future more and more. That is extremely important, and that is exciting. Yeah.
Yeah, and GridOS Connect, part of the solution, plays a really important part in enabling that by being able to manage your APIs and your integration points in between the data fabrics.
Yeah. And so something we forgot to mention, Paul, is, and of course we could speak for hours about the data fabric. It is built for operational use cases. It is built for utilities. That means high availability, disaster recovery is, of course, a capability that is in the platform. And as mentioned before, we are moving on, it is a platform that can be used to integrate and manage data coming from GE Vernova applications, but also from third-party applications. It's built to be operated both on-premise in a bare metal scenario, or you can run it in a private cloud. You can have workloads running in a public cloud, but you have a unified management environment because it's built in a completely distributed architecture. That is maybe extremely important to understand.
Yes, I might continue on. Yeah.
Yes, because I told you when we got to talk a lot. But what I also
yeah.
Go ahead. But what might be, and sorry, I'm just starting, and then you are adding. But what we also should discuss briefly is, of course, what is the difference? And I think some of the questions we saw in the chat also, and is related to it also, what is the difference between the GridOS Data Fabric and, let's say, an enterprise data fabric like Snowflakes, or maybe like a data fabric coming from the hyperscalers directly? And we might also want to highlight once again, what is the difference between GridOS Connect and the traditional enterprise service bus? And to do so, I want to recap simply, when we have designed and built the GridOS Data Fabric, including GridOS Connect, we always had grid orchestration, operational, real-time use cases in mind. That is important. So when we talk about the data fabric, when we talk about Connect, then everything related to real-time data or near real-time data or temporal data. So all the kind of data where you want to use it for forecasting, for orchestrating the grid, to run outage management analysis, the things where the real-time aspect of data is important. That is what the GridOS Data Fabric is optimized for. And then when you think about the data we are typically managing in the platform, that is data that you would use for grid operations and grid analytics. When I use an enterprise data fabric, now I'm thinking about the hyperscalers enterprise fabric, or think about a Snowflake. That is what I call an enterprise data fabric. These enterprise data fabrics you would typically implement when you focus more on historical data, if you think more about enterprise analytics, if you want to do a financial analysis, how your workers are performing, things like that. That is a typical enterprise use case. But when you think about grid operational and grid analytical use cases, where the data is either real-time, near real-time, temporal, and you always have this IT-OT integration gap, that is exactly where the GridOS Data Fabric is optimized for. Does it make sense for you, Paul?
Yeah. This slide I like, because it sort of brings in the real-time, near real-time, OT, IT and highlights where the GridOS Data Fabric is really sits. And I think it's important for when discussing with an IT group within your organisation about, why is this different to my data fabric that I got from that vendor? How does the GridOS Data Fabric differ from that? And I think you highlighted the points where it's built for utilities. It's built for integrating real-time data, integrating near real-time data, etc. So
exactly. But what I forgot to mention, and that is maybe, and by heart I'm an architect, an enterprise architect for utilities. The GridOS Data Fabric is not competing with the enterprise data fabric. We are working together. And that is the important thing, because an enterprise data fabric, as I said, is typically used and deployed in the IT environment, and it is designed and built to handle enterprise use cases, financial analysis, just one example, financial reporting. The GridOS Data Fabric is built for grid operations, for operational use cases, and the beauty is the GridOS Data Fabric can share the metadata catalog that you spoke about, Paul, with an enterprise data fabrics metadata catalog, so we can even enable a semantic integration between the enterprise world and the operational world, and that is quite powerful, I think.
And that goes back to breaking down those data silos and getting access to that dark data and understanding how you can easily make use of it, not spending all your time translating formats or creating things to do that. And I guess I'm going to bring this up because I know we're going to lead to it. I guess in the current world, with where the world has gone with AI in the last 5 to 10 years, maybe we should have a discussion about that before our hour.
That is a perfect one. And I love that you mentioned it, because I see we have some 7 minutes left in our discussion. So I think we can do some of the things quite quickly. The reason for that is simple, because we're going to be at Australian Utility Week. I'm going to be there. I'm going to do a presentation on AI applications and the future control room. So for those of you interested in learning more, and maybe you're at Australian Utility Week, I'm going to be there too to discuss more in detail also what we are doing on the AI side. But for now, I want to do just quickly, because the data fabric, what we spoke about with Connect and building the good data foundation, is of course the foundation for an AI-empowered control room or for AI-empowered grid operations. What is maybe important for us, it's not about the technologies just. It's not about machine learning or deep neural networks and deep learning, things like that, and Gen AI. Because let's be fair, Paul, you and me, we've been in the industry for many years, and we have done machine learning for many, many years. We have done neural networks for many, many years. We have done many of the AI. The only new thing in the world of AI at the moment, let's be fair, is Gen AI. The other thing that is maybe also important to understand is when we compare it 10, 15 years ago, of course, we never had access to the vast amount of data we now can leverage to build the AI models. So what has changed is the compute power, the accessibility of data, and of course, the Gen AI part. What is more important for us is, of course, how can we use the different AI technologies to create outcomes for our clients? And when you think about it, and now I'm running quickly, but typically you have 6 different types of AI applications. You have AI to automate tasks. And when you think about your daily life, Paul, you see many, many AI applications where the focus is on just automating tasks. You could even think about chatbots, things like that. The focus is purely automating tasks. The next section or the next type of AI applications is related to creating insight, meaning you have a lot of data and you use AI to extract insights from the data. And that leads to the next step, that you get more and more AI applications that help you to make complex decisions or that make complex decisions. That is the typical thing how you see different AI applications. Then you see more and more AI to create content. I'm not only talking about pictures and text and things like that. When you think about us as utilities, you can use it to create simulation data. You can use it to create simulated network data, things like that. And of course, augmented intelligence. When you're using your mobile phone, you're pointing somewhere and you get additional information. And the last part you typically see is human representation, deepfakes or automated presenters, things like that. So when we talk about AI, then it's more on the outcomes. And I think all of the different types of applications I was mentioning are, of course, important for the future utility. So I'm quite sure the future control room will have more and more automated tasks, more and more insight extraction, decision making. We're going to create more and more test and simulation data. We will augment the physical network with intelligence, all of these things. And that leads me in the end to a slide how we support it, Paul. And the data fabric, and that is maybe important, is explicitly built to support the AI-empowered future. And to make it short, because we are running out of time, as expected, the data fabric is both providing the foundation for operational transactional use cases, but it's also providing the good data you would need to train your models. And it's also providing you the integration environment to get your AI models into operational production. And with that, I think I have to jump to the summary slide.
I think that last point around supporting the future AI applications is getting your data in order, getting the data fabric as part of your environment and the utility, accessing OT information that was hidden away before, making it available for AI in the future is definitely a key part of why people should be looking at this sort of technology and this sort of platform as it's been put together. I recognize we're at 59 minutes now.
I'm sorry, I told you when I get in excitement mode. I'm so sorry.
No, that's fine. I just wanted to, before we end the call, just really say thank you to the audience for joining us, and I hope that we've provided you with some insights into the way that GE Vernova has prepared a data fabric and is really working towards improving the opportunity for a utility to manage their data better, and to support the use cases that we're talking about through the session. So they're my final words. I don't know whether you've got some final words there, Thorsten.
No, I think thank you all, of course. Yes. If you are interested, please feel free to connect with Paul and me on LinkedIn. And there is a final slide. Let me see when I find it. I think it should be the last one. Oh, sorry. This one. If you are interested in getting some more insight on the AI, what I briefly mentioned, feel free to read it, download, just take the QR code here. And otherwise, I think and I hope we're gonna meet at Australian Energy Week.
Yeah.
And that's it from my side. Thanks, Paul, for having me. And maybe you wanna quickly wrap up.
Yeah, I think we've wrapped up. I know there's a number of questions in the chat that we haven't got to, but I think the team will try and get responses back on those. But yeah, I just want to say thanks to everyone, and thank you, Thorsten, for getting up early there in Norway and giving us a really good overview of the data fabric. And yeah, okay, so thank you, everyone, and we're done now. Thanks. Bye-bye. Okay.
Bye.